Yeah, hello friends. So today we are going to see like how we will be writing or why we are using float and double data type. Okay, so basically like in the previous sessions, we already covered what are the different data types like integer, character. Okay, so I think all clear about it. So today we will see even like you people are aware. Okay, so there are some primitive data types called float. Okay, so float is just to hold some floating point like values. And maybe you are aware about double. Double is a data type. So there also I'll be able to hold like the floating point values. Okay, but double of course will be like that will be the larger data type compared to the float. Okay, it can be the double size of float. So like the basic idea is that double will be able to hold a bigger floating point value. That's it. But let's see how or why we are using this real numbers. Okay, like in C programming, what is application? Okay, and how we can represent that in some better way, right? So let's see the like different format specifiers. Okay, for float, how will be what is a format specifier, and for double, what is a format specifier? Let's see that. Then after that, I will just tell you like what are the real application. Okay, so for example, if you want to hold some bigger values and all, I have some value. Okay, so charge of an electron or maybe the speed of light. Okay, so that all will be some bigger value. We used to write it as 3 point something, okay, into 10 to the power 8. Okay, so instead of writing 3000, so we used to use this notation. Okay, so like in maths, so the same thing we are actually about to implement in C programming. Okay, so there we can get the help of scientific notation of the real numbers. Okay, so that I'll explain, I'll show some examples so it will be clear, right? Yeah, so let's move on to that. Yeah, so here you can see like how we will be able to write a scientific notation. You must have done in maths, okay, how we'll be representing a bigger number, okay, in the like using the scientific notation. So you can see here like there's a variable, okay, a, and into 10 to the power n. Okay, so where a value will be, of course, will be between 1 and 10. So usually we used to write 5 point something or 6 point something. Okay, so 10 point something. So it will be usually not 10 point, at least 9 point something. So usually the value a will be, of course, will be between 1 and 10, and n will be the integer. So the power integer, it can be positive or negative. Okay, so you can see one example here. Here we written 5.63 into 10 to the power 5. So everybody is aware, right, how we'll be calculating this value. So 5, then like if you're multiplying this with 10 to the power 5, so 563, so like two things are over. Then again 3 zeros. So the value will be 563,000, 3 zeros. That's it. But of course, it's better to write like this in this scientific notation. So it will be short and maybe the readability is better. All right, so like that. Okay, so a value you can see here, it is a value was 5 point something, it was less than 10. Maybe in the second example, let's written 2.0 something. Of course, it is less than 10. So this kind of notation we will be using if you want to like store some bigger data and bigger numbers, and if you want to do some like equation solving. Okay, so any arithmetic operation. So I think we'll try to do something called E equal to mc square. Okay, so let's try to solve that equation in C program. Okay, so there I'm going to use the scientific notation. Okay, so there I'll be using the speed of light. So it is around 3 into 10 to the power 8. Okay, so the scientific notation we'll be using, and we'll be trying to find the energy using this E equal to mc square equation. Yeah, now you can look at the some other example. Okay, so it's not about for positive values, even for some like we can write in the power, we'll be able to write some negative numbers. So you know negative numbers, like we'll be using that if the value is very small. Okay, so 0.00137. So instead of writing like that, we can make I told already a is always between 1 and 10. A means this notation if you remember. Okay, so we can make it 1.37. Okay, so 1 point. So you know the decimal has to be shifted. Okay, so 3 places. Okay, so shifting 3 places. So that's the reason we written 10 to the power minus 3. I hope all clear about it. Maybe you have done it in maths. Okay, so we just revised that concept. And now let's see what is the format specifier if I want to use scientific notation. Okay, so the other format specifier, I think all clear. Okay, so now I'll show that format specifier for scientific notation. It is E, that's it, percentage E. Okay, so yeah, before moving further, I would like to quickly discuss something about float and double, okay, and long double. So long double will be the largest data type, okay, so in C programming, C or like other programming language. So you can see the storage size for long double is 10 byte. Okay, so we started with character that was only 1 byte. Okay, so here we are talking about long double which can hold 10 byte. Okay, so that is fine, absolutely fine. Now I would like to differentiate what you mean by float and what you mean by double. Okay, so you look at here. Okay, so you will be able to see the type is float, which is taking 4 bytes of memory. Okay, all right. And the value will be able to see the value range. Okay, so they already use scientific notation. What is it? 1.2 e to the power minus 38. Okay, so you understood, right? 1.2 e to the power minus 38. Instead of that, we could have write 1.2 into 10 to the power minus 38. That's it. So that's basically the scientific notation and to this value. Okay, so that's a large range. Okay. And one more thing we have to note it down. So for floating point data type, the precision is up to 6 decimal places. Okay. So after the point, that means after the decimal point, up to 6 places, we will be able to get a precision. Okay. But sometime I'm using some value. Okay. So there I want to get the precision up to 10. Okay. 10 places or 15 places. Then in that case, I can't use a simple float type variable. Then what I should do? I have to use a double type variable. Of course, double type variable unnecessarily don't use it. Okay, so you can see the storage size is 8 byte. Okay, it is very necessary if it is important, and if you want to get that much 15 decimal places precision if you want for certain value, then only you are supposed to use double. Okay, or else we understood that the storage sizes of course is maximum. Like it's of course a double of the float. Okay, so almost 8 bytes. Okay, then one more we have long double. Okay, so that is the biggest one, and here we will be able to say 9 decimal places of precision we are able to get it. So just keep this things in mind while writing the program. So as per the requirement, we will be deciding whether float or double or long double has to be chosen. Okay, so what you have to choose. Okay, and yeah, so what is the precision, for how many decimal places you need precision, accordingly we will be doing that. All right, so now let's move on to the programming, and I'm thinking that we will try to solve this equation. I think all are clear, right? Means all are very familiar with this equation, E equal to mc square. So here we'll be able to calculate the energy in joules. Mass will be measuring it in the kilogram. Okay, and c is something called speed of light, and you'll be able to see that's the value 3 into 10 to the power 8. It's not 108, it is 3 into 10 to the power 8. Okay, so that we will see. So that equation means that this value general will try to implement using scientific notation, and then we will be finding the energy. It's very simple thing. Okay, so mass you can assume anything, whatever you like. All right, so yeah, now we will move on to the programming. Yeah, so now you please look at my screen. Just look at this program. It's very simple. I just declared one variable called speed. Okay, so float, the data type is float and speed, and I written some values, 3 point something, I think. I written 15 decimal places, whatever you like. Okay, so it's some not bigger value, 3 point something. So that's the value, but we were actually after the decimal. Okay, so we were adding, we were actually keeping more places. That's it. And as usual, usually, if you want to print, okay, so the floating point value will be using the format specifier as %f. That's it. Okay. So speed and the value, and the variable is speed variable. That's it. So let's see. I already, I'm just building this project. Just you click on build project. I think all are clear. I already done this. Okay. So that's the reason it's showing. Then I am just clicking on run as local C++ application. So as per the understanding, since it's a floating point value, we know, we already discussed that. So float data type will be having 6 decimal places accuracy. Okay, the precision will be there for 6 decimal places. That means after the decimal point, we'll be able to get 6 places. Let's see. Let's try to verify it. Okay, so yeah, perfect. You will be able to see that 3.897869, whatever the value. So after decimal point, 6 places accuracy I'm getting. Okay, all right. So now I would like to print some in different way. What I would like to do, maybe even I have the option, I can specify after decimal places, after the decimal point, how many digits I want to get, which I can specify here. Instead of writing %f, I can write, for example, 0.2f if I need only 2 decimal places. Yeah, so let me do the same process. Okay, again I am building. Okay, each and every time whenever you are making any changes, if you want, you can do the build project option. Again I am running. So you will be able to see that. Okay, see here, I am able to get after decimal point, I am getting only 2 places, which I specified here, 0.2f, no problem. So now I know the precision for floating point data type is only 6 places, right? Let me see, let me check whether that's correct or not. For example, here instead of writing 0.2, I am writing 0.10. Okay, so after the decimal point, I am actually expecting 10 decimal places, 10 digits. Okay, so let's see whether it is able to print it accurately. Yeah, so of course it shouldn't be. Okay, so yeah, as per the understanding, it shouldn't print 10 decimal points in accuracy. It should be printing only 6 points. Okay, after that we should get something else. So let's see, okay, 10. So 3.8968. Okay, so till this, see here, I'm not getting 9 here basically. So instead of 9, it is showing some other value. Okay, so which is totally different. I'm not very sure whether you are able to compare it or not, but at least you can like see here. Okay, so this value and all I never entered 717, which is not there here in the original value. So what is happening? Like six decimal places only I am getting with the precision. Okay. Yeah, so rest all I am getting, okay, some random values I am getting. 9 you are not getting, 8, 6, 9. So instead of 9, it's just printing the consecutive values. Okay. So the accuracy is not there after 6 places. Now for this accuracy, what I can do, I already told you, like next to float, we have something called double data type. So instead of float, what I would like to do here, I'll be writing double here. Okay, so double speed and the same value. Okay, if you want to print a double value, so the format specifier is LF. Okay, so LF and the speed, I'm just writing the speed. All right, so and for the other one, we'll be using, if you want certain decimal places, we can do that. Okay, so let's see, let's run the program. Now you can see I just changed the data type to double. Okay, so double speed, the same thing. And I'm just writing printf. The format specifier is LF, as I told already. So in the first line, I simply printed LF. Okay, so the floating point value which I'm expecting. Okay, but I'm writing that's in the double format. Okay, so point to LF I'm getting. And here I am getting, I written 0.10 LF. So after decimal point, I am expecting 10 places. So let's see whether it is accurate or not. So you'll be able to see that the value is almost correct. Maybe it's very difficult to check it. Okay. So far we discussed. Okay. So the accuracy will be there for 15 decimal places. So let's do this program. All right. So you can see the same value we are expecting. Okay. So the same value we are expecting. So you can see here 15 decimal places. I am getting till 3, 4, 5. Okay. So till here I am getting. Alright, so that's fine. Now I think it's clear for all. Okay, so why we are using float and where we are using double. Okay, so double we will be using only when we need more precision in the value, like after decimal places. So it's better to specify after decimal places, okay, how many digits you need. Okay, so like instead of writing LF, you can clearly write 0.2 LF. Okay, so two digits you need after decimal point. So 0.15. Okay, so I'm expecting 15 places after the decimal point. Yeah, so like that you can write it. All right, so I think it's clear. Even though like this is not still if like enough, then you can go for long double option. All right, so I think that's clear. Now I was talking about the scientific notation. So for the same value, let me show you how I can use the scientific notation. So the format specifier is like a percentage E. Okay, so whether it is like floating point value or the double data type, whatever the data type it is. So if you need to get the scientific notation, we'll be using percentage E. Let me write this program. I'll just like modify it. Yeah, so here you can see I just written the same value, almost same value. But what I written, the data type is float. Okay, so the variable is speed. So instead of writing 3.8 something something, what I have done here 3.89 e to the power 10. Okay, so it's like into 10 to the power 10. Okay, so the same thing we have done with the exponential e to the power 10. And if I want to print the value, either I can use the percentage f if I want to print that as a floating point value, and I can use the like format specifier percentage E if I want to print that in the like the exponential form. Okay, in the scientific scientific representation, if I want to get, I can use percentage E. Okay, let me run the program once again. All right, so it'll be here, like you'll be able to see that initially it's showing the value 3.89 into 10 to the power 10. Okay, so it should be like that 389 then 00 something. We are just adding. Okay, So here you will be able to see in the like percentage f, if I am using format specifier, after decimal places I am able to expect only 6 decimal places. Okay, but percentage e will be able to print the same value. Okay, so the same value in the like the scientific notation in that format it is able to show. Yeah, so here also we can do the same way, like after decimal places we can demand. Okay, so we need this many places. So here for this value I just added few more digits. Okay, after decimal places here in this variable declaration. Then if I need, okay, so I need maybe zero point 0.6, okay, 0.6 decimal places in the floating point representation. Of course it's possible. For floating point we already discussed that the precision is up to 6 places, right? And here also I'm just writing 0.6. Okay, so maybe more than 6 if I'm writing. Let's see, the like after 6 the values. Okay, so the values which is appearing can be any garbage value, we can't trust it. All right, so let me show you right now. Okay, so you can see here like in the first representation 6 decimal places I'm expecting, so you will be able to see that 3.89 something. Okay, so 3.896785. Okay, 6785 exactly. So we will be able to get here. Okay, so till here we are getting. Okay, so the proper values we are getting. After that we can't trust it. After 6 places, like it can be any other garbage values or something. Anyway, we are expecting after decimal point 6 places accuracy. All right, so that's done. And here you will be able to see 0.8e. Okay, so in scientific notation also I'm expecting after decimal places I need after decimal point I need 8 places. So here also I can expect only 6 places precision. Okay, so then like it's just making e to the power 10. That's it. I hope it's very clear. Like for real numbers and all, practically if you're having some measurements, okay, usually in equations and all, we'll try to use the scientific notation. The same thing you can use for double. So in double, like the precision will be more. Okay, so we can get up to 15 decimal places properly. So double you can use. Okay, so here normally for double we'll be using this. Okay, I can build the project. So like we'll be running it. Okay, all clear, I guess. Even we can use negative values also. Okay, so we'll be able to see this is how double data type it's handling. It's holding the value. Okay, so now we can even keep negative values here. So I will be able to use the sign, negative sign here. Okay, so that's fine. The same logic. Everything is same. The negative sign will be there as it is. All right, so you'll be able to see the negative value. Okay, here I am actually looking for 8 decimal places. Of course, I can get 8 decimal places properly since it's the double data type. I already changed it to double data type. All right. So now, as I told already, we'll be doing one program. So in that program, we'll be calculating like the energy E equal to mc square. Okay. So I'll create a variable speed. Speed is 3 to the power. Okay, so 3 into 10 to the power 8. I think it's clear. All right, so let me write that. Yeah, so here you can see like I just modified the speed variable. Okay, so speed is double, the data type is double. I want to write it's only 3 into 10 to the power 8. Okay, so 3 into 10 to the power 8, which I represented as 3 of E8. Okay, both are same. All right, so that we have done. Then after that mass we are just assuming 5 kilogram. Okay, so double energy I'm calculating, energy equal to speed into mass. Okay, so it is E equal to mc square. Okay, so the speed should be square. Yeah, so right now you can see the equation I written. Okay, so like Einstein's like famous equation E equal to mc square. Okay, so I written that like energy equal to, okay, so mass into speed, c square. Okay, so that's it, very simple. So here speed like data type is double and mass data type is float. Of course, after multiplication, like the result we are expecting that the result data type will be double. Okay, so the bigger one. So that's the reason for energy I took the data type as double. And yeah, that's it. So I'm just printing the energy in the scientific notation. Using scientific notation I'm printing. I'm using double data type, so don't write only E. So you can write simple E if it is the floating. Okay, so if the data type is float, like if you are using double data type, just try to write LE. Okay, so before we used to write, now for float it is F and for double it is LF. Similarly, even for scientific notation, you can write E for float and LE for double. That's it. So let's see, zero point 0.6 LE. Okay, so after decimal point, I am just planning to get the precision for 6 places. Okay, if you want, you can extend that up to 15 because since we are using double data type. Let's see, let's run the program. All right, so we'll be able to see the energy is 4.5 something, okay, into e to the power 17. Okay, so it's a simple maths calculation. We multiplied speed into speed. Okay, so I just written that inside a bracket, then into mass. I hope it's clear. Okay, it's nothing complicated. I just want to show you that. So if the values are bigger, okay, so like too much big, or if the values are very small, okay, so you can use the scientific notation. So whenever we are using the scientific notation, we are supposed to use the format specifier as E. Okay, and also I try to like emphasize, or I try to clarify that what's the difference between float data type and what's like what you mean by double data type, and when we want to use float and when we want to use double. Okay, so and the format specifier for floating point value will be the like E. I can write always in this like it's a better method like percentage dot, then we can, okay, up to how many decimal places we need, we can write that value. And for double, I told that we will be using LE, that's the format specifier. I hope it's clear for all. Okay, so I'll be giving one assignment. Okay, maybe something with some other value. Okay, for example, the speed of like speed of light we already done. The charge of electron. The charge of electron will be a very minute value. It can be 10 to the power minus 19. Okay, so let me add one assignment in the assignment session. All please do that. Try to do that. Try to practice it. All right. So that's it. Thank you all. We will meet in the next session.